In this video, I'm going to talk you through the most common mistakes that people made on last year's exam, so that you don't make the same mistakes this year on your exam. I've got all the information from the examiner's report from last year. Keep watching right till the end of the video because each of these points are valuable marks. So at number 10, less than a quarter of people got this correct in their exam. When a fuel burns, carbon dioxide and water vapour are produced. Why is it water vapour rather than liquid water? And that's because the fuel burns at a temperature higher than 100 degrees C, which is above the boiling point for water, so it will be a gas. At number 9, what environmental problem is caused by particulates that are produced by a burning fuel? Well, the problem is global dimming. This is where those tiny particles go up into the atmosphere and block out some of the sunlight reaching the Earth. At number 8 on our top 10, if you filter a sample of water to try and clean it up, why will there still be some dissolved solid particles in the water even after it's been filtered? And that's because the dissolved solid particles are very small, so they can pass through the filter paper. Number 7. During chromatography, why do the different components in the mixture separate? That's because the different components have different solubilities, so they move at different speeds. The ones that are more soluble travel faster and therefore reach higher on the paper. The ones that are less soluble travel slower and they get left behind lower down on the paper. Number 6. How can you test if a water sample is pure? Well, first you need to determine the boiling point of the water, and pure water should boil at 100 degrees C. So now we're into the top 5. Why is crude oil not a formulation? Well, you need to remember that a formulation is a mixture that's been specially designed to be a useful product, and all the components of that mixture have been measured out into exact proportions. Now, while crude oil is a mixture, it's not designed to be a useful product. In fact, crude oil isn't very useful at all until it's undergone fractional distillation. The other thing about crude oil is the different components of the mixture are not carefully measured out in exact proportions. The fourth most poorly answered question on last year's chemistry exam was, how do greenhouse gases cause global warming? So first of all, you need to say short wavelength radiation from the sun passes through the atmosphere. This is absorbed by the Earth and re-emitted as long wavelength radiation. This long-wave radiation is absorbed by greenhouse gases in the atmosphere and re-emitted in all directions, and some of that comes back down to Earth. This means it increases global temperatures. The next two on my top 10 relate to practical skills, and they were only answered correctly by about 4 or 5% of last year's candidates. So now is a good time for me to include a link to my playlist of AQA required practicals that relate to paper 2. So at number 3, why does measuring out 20 centimeters cubed of a chemical give less accurate results than measuring out 50 centimeters cubed of a chemical? And that's because if you make an error measuring, for example, if you measure out 1 centimeters cubed too much, it will be a bigger percentage error if you're measuring out a smaller volume. So if you're still watching the video, please give it a like because it helps me realise what people are finding useful and it encourages me to make more videos like this. So at number 2, be able to suggest a systematic error in a practical. Not many people could do this. So a systematic error is one that is wrong by the same amount in the same direction each time. For example, if a balance hasn't been reset to 0 and it reads 0.5 grams at the start, any measurements of mass will all be too high and will all be out by 0.5 grams. Whereas a random error could be too high or it could be too low and it will be out by different amounts each time. So we now get to the worst answered question of chemistry paper 2 last year. With only 4% of candidates getting this one correct, even many of the people who got grade 9s last year wouldn't have got the marks on this question. So why does the volume of a reactant not affect the rate of reaction? So what we mean by this is it doesn't matter whether you use 20 centimeters cubed or 50 centimeters cubed of the reactant. And the first mark is for saying the concentration isn't changing, so you still have the same number of particles per unit volume. So whether we have a small volume or a large volume, the particles aren't any more or less crowded. And that means there will be the same frequency of collisions between the reactant particles. So if you've enjoyed the video, remember to click subscribe. Thank you for watching.